everyone, welcome to the One Cone Cam channel. So in this video, we will dive deep into the fascinating world of database management languages. Specifically, we'll explore the two prominent figures in the field, which are the SQL and NoSQL. The objective of this presentation is to provide a comprehensive understanding of databases, SQL and NoSQL, as well as their practical applications and differences. Specifically, we will cover explaining the concept of a database as a structured data storage system, providing an overview of SQL and NoSQL databases and their respective characteristics, discussing the significance of SQL in the context of relational databases, its ideal use cases, and examples of companies effectively using SQL. And then we will also examine NoSQL databases, their non-relational nature, suitable scenarios for their use, and instances of prominent companies utilizing NoSQL solutions. And then we will be highlighting the key distinctions between SQL and NoSQL databases. And lastly, we will be conducting a comprehensive comparison to help you make informed decisions when choosing between SQL and NoSQL for your specific projects and applications. So without further ado, let's get started. Let's start by discussing what a database is. So a database, this is an organized collection of structured information or data, typically stored electronically in a computer system. So it is a structured collection of data that is organized for efficient retrieval and manipulation. It acts as a repository for storing, managing, and retrieving information. Simply put it, as all the stored information are input of the user that was saved on the computer system. So databases are used to store and organize data for a variety of purposes, such as managing customer records, tracking inventory, and processing financial transactions. Think of your database as a library building, okay? So imagine the library itself as a database. It's a structured system designed to store and manage a vast amount of information, which will be the books, efficiently. So in a library, we have a vast collection of books, right? Just like in database stores, a vast amount of organized information. Now let's consider the tables as bookshelves. So in the library, you have different bookshelves dedicated to specific topics or genres, like for example, fiction, non-fiction, science, etc. So each bookshelf can be compared to a table in a database. Tables in a database store related information or where specific types of information are stored. Now, let's consider those records or rows as the books. So, on each bookshelf, you have individual books. These books contain detailed information about a specific topic or story. So, in the context of a database, each individual book can be seen as a record within a table as it holds a collection of related data, or a row in a table since it contains specific information related to a particular item. And then let's consider the columns or the fields as our book attributes. So inside each book, you have various details such as the title, the author, publication date, and genre. So these details can be compared to columns or fields in a database. So fields store specific pieces of information about each record or stores a specific type of data. And then lastly, let's consider the database administrator as the librarian. So the librarian manages the library, ensuring books are organized, helping patrons find what they need, and maintaining the overall order. In the database analogy, a database administrator performs similar functions, managing data, ensuring data integrity, and facilitating access to information. So by drawing these parallels between a library and a database, this analogy helps to convey the basic concepts of tables, records, fields, and management of information in a structured and organized manner. Just as libraries make copies of books for backup, databases create backups to ensure data is not lost in case of a system failure. Now, databases are managed using a database management system, in this case, SQL and NoSQL. Okay, so now SQL and NoSQL. Sometimes other people pronounce this as SQL and NoSQL. But yeah, both methods are used to store data effectively, but they vary in their structures, relationships, scalability, language, and support. So this too would be the ledger itself or the platform on which how the data will be stored. For example, the SQL would store data on a tabular manner containing the data, whereas the NoSQL would have more freedom on how the data would be stored and presented. Basically, as their name suggests, they provide users with a way to manipulate as to how the data is managed and stored in a database. So now, let's find out about each type of database, how they are similar and different, how to find out which type of database is suitable for your application. And with that being said, let's now discuss the first database management language or system, which is the SQL or the SQL language. Okay, so the SQL stands for Structured Query Language. So in the 1970s, SQL was developed at IBM by Donald D. Chamberlain and Raymond F. Boyce. This programming language has since become a cornerstone for managing data in relational databases, contributing significantly to the field of information management. One of the key principles of SQL is to reduce data duplication. This is achieved by storing data in tables. So SQL uses tables with rows and columns to organize data. So each row represents a single entity, like a customer, a product, or an order. And each column represents a field of information that all entities possess, like the customer's name, the product's description, or the order date. The most common SQL commands for managing data in relational databases are the select. So this is used to retrieve data from one or more tables. Insert. This is used to add new data to a table. And then we have the update. This is used to modify existing data in a table. And then the delete, which is used to remove data from a table. And then we also have here the create and drop. Create for creating a new table, and then drop for deleting an existing table. SQL is the most widely used language for implementing queries in relational databases. So it is a declarative language, meaning that it tells the database what to do without specifying how to do it. So this makes SQL easy to learn and use, even for people without a background in programming. And lastly, SQL is an interactive language, meaning that users can type SQL commands and receive results immediately. So they efficiently store and provide access to related datasets, forming the backbone of modern data management. So when we say relational database, these are a type of database that stores data in tables. So the tables are linked together by relationships, which allow the data to be efficiently accessed and manipulated. So a relational database is a collection of one or more tables, which are organized into rows and columns. So here, the data is organized, assessed, and stored according to the relationships. This is a good choice for applications that require complex queries and transactions, large volumes of structured data, and high reliability. So this is also the most popular type of database management system. They are used by a wide range of organizations, from small businesses to large enterprises. So some of the most popular are DBMS, include MySQL, PostgreSQL, Microsoft SQL Server, IBM DB2, and Oracle Database. Okay, so now let's figure out when to use SQL. So first is efficiency in related data. So SQL excels when working with related data, making it an ideal choice for tasks involving connections and relationships. Relational databases driven by SQL also offers efficiency, flexibility, and easy accessibility from any application. Next is real-time updates. So SQL-based systems automatically refresh data across all instances when a record is updated, providing a real-time information. So the changes made by one user to a specific record automatically refreshes across the entire database in real time. So this dynamic update feature is a significant benefit of relational databases. Next, when you need to handle large amount of information. So SQL and relational databases are adept at handling large volumes of data, offering a centralized solution for data access and management. So this provides a single, flexible point of access to information, avoiding the need to modify multiple files. Next is for data integrity assurance. So SQL is excellent for ensuring data integrity within databases. So they ensure accuracy and reliability in information storage and retrieval. Next is straightforward communication. So SQL is the most straightforward language for communicating with relational database management systems. And then we have customization and analysis. So this is ideal for analyzing and customizing behavioral related sessions. It also enables the creation of unique dashboards for efficient data representation. Next is simplicity and speed. So we've mentioned that SQL is the straightforward language for communication with relational database management systems, enabling fast data storage and retrieval. And then we have here complex queries and joins. So SQL shines when complex queries and joins are necessary for sophisticated data analysis. So it is the go-to choice when you need to perform complex queries, utilize joins, and customize behavioral related sessions or create unique dashboards. And lastly is industry adoption. So this is widely used by major companies like Uber, Netflix, and Airbnb. Even major organizations like Google and Amazon have built their own database systems using SQL to query and analyze data. So in summary, SQL is the go-to choice for managing related data efficiently, ensuring real-time updates, handling large data sets, and maintaining data integrity. Its simplicity and power make it indispensable for major organizations in diverse industries. Now let's have its use cases and examples. So first, we have transactional systems. So transactional systems are systems that process transactions, which are operations that update the database. So transactions must be ACID compliant, which means that they must be atomic, all or nothing, consistent, which is the database must remain in a valid state after the transaction is complete, and then isolated, which means that each transaction must be independent of other transactions, and lastly, durable, which means the changes made by the transaction must be permanent. So SQL databases are well suited for transactional systems because they support ACID transactions. Some of the transactional systems that use SQL database include banking systems, e-commerce platforms, airline reservation systems. Next is for complex queries and aggregation. So SQL databases are strong at handling complex queries, aggregation, and reporting tasks. So complex queries are used to filter, join, and manipulate data from multiple tables. Aggregations are used to summarize data, such as calculating the average, count, or sum of a column. So some examples of applications that use complex queries and aggregations include business intelligence applications and data warehouses. We also have here the Amazon Redshift and Google BigQuery as some of its examples. Next is data integrity and validation. So SQL is suitable for applications requiring strong data integrity, validation rules, and constraints. So data integrity is the accuracy and consistency of data. Validation rules and constraints are used to ensure that data is entered and stored correctly. Some of the applications that require strong data integrity and use SQL includes healthcare record systems and government databases. Next is we have the relational data modeling. This is a way of organizing data into tables with relationships between the tables. So SQL databases excel in managing relational data because they have built-in data model that supports tables and relationships. Some of the examples of applications that use relational data modeling and SQL database include customer relationship management or the CRM systems, human resource management systems or the HRMS. And the next is we have the content management system or the CMS. So these are software applications that help users create, manage, and publish digital content. So CMS are commonly used to create and manage websites, blogs, and other online content. And then SQL databases are ideal for use in CMS because they provide a structured and efficient way to store and manage its content. So SQL databases also support complex queries, which allows the CMS to retrieve and display content in a variety of ways. Some examples of how SQL databases are used in CMS include page content, user accounts and profile, comments and feedback, tags and categories, and media files. So WordPress and Drupal also use SQL databases. And then we have here the enterprise resource planning or the ERP systems and the business intelligence or the BI. So ERP systems are software applications that help businesses manage their core operations such as finance, accounting, human resources, manufacturing, and supply chain management. Meanwhile, business intelligence or the BI tools are software applications that help businesses analyze their data to gain insights and make better decisions. So SQL database play a vital role in both ERP and BI systems. ERP systems use SQL database to store and manage data about the business's operations, and the BI tools use SQL databases to retrieve and analyze this data to generate the reports and insights. So overall, SQL databases are essential for ERP and BI systems. They provide a structured and efficient way to store and manage data, which allows ERP and BI systems to provide businesses with insights they need to make better decisions. Okay, so some of the examples are the SAP and tools like Tableau and Power BI interact with SQL databases. Now let's move on to NoSQL or NoSQL. So a NoSQL or NoSQL database is a non-relational database, hence no in its name. It is also defined as not only SQL. Okay, so NoSQL databases do not use the traditional relational data model, which stores data in tables with fixed columns and relationships. Instead, NoSQL databases use a variety of data models such as key-value pairs, column-oriented graphs, document-oriented structures. So we will see all of this later. And this makes NoSQL databases more flexible and scalable than relational databases and better suited for storing and processing large amounts of unstructured data. Okay, so Carl Strauss coined the term NoSQL in 1998 to describe the growing trend of non-relational databases. Strauss was frustrated with the limitations of relational databases, such as their lack of scalability and flexibility, and then he saw NoSQL databases as a way to overcome these limitations and provide a more efficient and scalable way to manage the data. So NoSQL databases began to gain popularity in the late 2000s as web applications and other applications become more complex and data-intensive. So the traditional relational databases were struggling to scale to meet the demands of these applications, and NoSQL databases offered a more scalable and flexible alternative. So NoSQL databases are also well suited for agile and DevOps practices, which emphasize a rapid development and continuous delivery, and they are easier to schema-less, okay? Making it easier to make changes to the database schema as needed. So this makes NoSQL database as a good choice for agile and DevOps teams. So NoSQL databases are ideal for dispersed data repositories with large storage requirements. This is because NoSQL databases are typically horizontally scalable, meaning that they can be scaled out by adding more nodes to the cluster. So this makes NoSQL databases ideal for applications such as big data analytics and real-time streaming data processing. And then NoSQL databases can store structured, semi-structured, and unstructured data. This is because NoSQL databases do not have a rigid schema, which means that they can store data in any format. This makes NoSQL databases ideal for applications that need to store a variety of different data types, like social media data, IoT data, and sensor data. Next, as they are schemaless, meaning they do not have a fixed schema. This makes NoSQL database more flexible and scalable than relational databases. It also makes it easier to use with new and emerging data types. And lastly, NoSQL databases uses a variety of non-tabular data models, such as key-value pairs, column-oriented graphs, and document-oriented structures, like we mentioned a while ago. So these data models are more flexible and scalable than the traditional relational data model. Okay? So when we say non-relational databases, they are often more flexible than relational databases. They are also better suited for storing and querying large amounts of unstructured data. And there are several reasons why non-relational databases have become popular in the recent years. First is that they are more scalable than relational databases. This means that they can handle large amounts of data without sacrificing the performance. Second is that non-relational databases are more flexible than relational databases. This means that they can be used to store a wider variety of data types, and they can be adapted to meet the specific needs of different applications. So this is a good choice for applications that need to store large amounts of data, requiring high scalability or need to store flexible data models. They are also a good choice for applications that need to handle real-time data processing or offline data access. So these are some of the examples of non-relational databases, which are the MongoDB, Apache Cassandra, Redis, Apache HBase, Amazon DynamoDB, Google Cloud Bigtable, Microsoft Azure Cosmos DB. Now let's move on to the different NoSQL types. So first is we have the key-value pair-based. So key-value pair storage databases store data as a hash table, where each key is unique and the value can be a JSON or a binary large object, string, etc. So you think of them as a dictionary. So this dictionary has different sections, each representing a specific piece of information. So every section has its own special name, like a keyword. So when you want to find something, you just use that special name, or which is the key, and you get the information, which will be the value related to it. So this information could be a number, a word, or even more sets of names and information. Now, the cool thing about key value pairs is that they don't need a strict structure, unlike traditional databases that require you to plan things out in advance. So these key value databases are very flexible. This flexibility makes them super fast as storing and finding information. And because you don't need a lot of rules and guidelines, they're easier on your computer's resources, which means that they can run smoothly and quickly. So an example of this would be the DynamoDB, Redis, and Berkeley. Some of its use cases would be storing session information, user preferences, shopping carts, or product recommendations. Now we have the document-oriented. So document databases makes it easier for developers to store and query data in databases by using the same document model format that they use in their application code. So imagine a simple or a special kind of database where data is kept like keys and values. But the interesting part is that the value. So instead of just a simple word or a number, it's like having a mini document. So this document can be stored in formats like JSON or XML, kind of like special computer languages. Okay, so in this type of database, you don't need to tell exactly how things should be. It's like having a data store that understands information in the form of a JSON object, which is pretty flexible. So this makes it really handy for things like managing websites, blogs, checking real-time data, and handling online shops. However, it's not the best for really complicated tasks that involve a lot of steps or different types of information all at once. So it's more like a quick and flexible tool. Unlike some other databases, you don't need to make sure everything follows strict rules. For example, one special database called Apache Cassandra doesn't need every row to have information for every column. Like other databases, it uses a special technique called hashing to find and fetch the right pieces of information. So example of this would be the MongoDB and CouchDB. Now as we have the graph-based. So graph-based represents data with nodes, edges, and properties focusing on relationships. So in this system, each thing is like a dot, which would be the node, and the connections between them are like the lines, or that would be the edges. So in a graph database, things are closely connected, unlike in a regular database where they are more loosely linked. So it's like having a map where places are dots and the roads between them are lines. So each dot and line has its own special name or number, making it easy to find and connect things quickly. So this kind of database is great for tasks like figuring out routes, exploring social networks, or dealing with location-based information. So people use these databases for things like planning routes for deliveries, connecting friends on social networks, risk assessment, fraud detection, and finding places on a map. So an example of this would be Neo4j, FlapDB OrientDB, Allegro Graph, and Infinite Graph. And the next is the column-oriented. So this organizes information efficiently for various applications. So wide column NoSQL databases are a bit like a giant table with rows and columns similar to what you'd find in regular databases. However, what makes them special is that each row in this table can have columns with different names and formats. These databases are like math wizards when it comes to adding up numbers or finding averages because they organize data neatly in columns. They are commonly used in places where there's a lot of data to manage, such as keeping track of products in a store, creating business plans, or organizing library catalogs. And when it comes to the types of columns, you'll encounter two groups. The standard column families, which are like keys that open up a collection of columns, and super column family, which are like keys that open up a bunch of different groups of columns. So some of the use cases of this would be Google's Bigtable, Cassandra, and HBase. And since we all know that NoSQL databases are non-relational databases that are designed to store and manage data that is not well suited for relational databases, here is when to use a NoSQL. So first is for fast availability of big data. So NoSQL is advantageous when the rapid availability of large datasets is crucial. And the next, it is suitable for companies that need to scale dynamically due to changing business requirements. So NoSQL is a good choice for data that requires a flexible schema, allowing for dynamic and evolving data structures. And the next is NoSQL is known for its user-friendly nature, flexibility, and high performance. And you should also opt for NoSQL when handling extensive datasets or requiring flexible data models. And then NoSQL is a good fit for managing large amounts of unstructured data and document-oriented databases such as CouchDB, MongoDB, and Amazon DocumentDB. And then next would be scalability and horizontal scaling. So NoSQL databases like Cassandra, which is developed by Facebook, offers scalability and support horizontal scaling. It handles massive data across various servers with no single point of failure. And then you should use NoSQL when the traditional relational database management system, or the RDBMS model, is inefficient or insufficient for your data needs. And then we would use NoSQL for keeping track of temporary data such as shopping carts, wish lists, and session information. And lastly, companies like Facebook, Amazon, Google, Netflix also rely on NoSQL systems to manage their extensive datasets effectively. Okay, for its use cases and example, so NoSQL databases are often used for applications that require high scalability, performance, and flexibility. So it uses base consistency model. So base stands for basically available, which means that all users can perform a query. So the database spreads data across several systems. So in case that a failure happens to a segment of data, the database will not experience a complete outage. And then S for soft state, which means that the database state can change over time. And lastly, eventually consistent. So if the system is functioning and we wait long enough, the database will eventually become consistent. So the advantage of the base consistency model is that transactions are committed faster. The databases that use the base model prefer availability over consistency of replicated data. Okay, so some of its use cases and samples is the big data and real-time analysis. So the NoSQL database are well suited for handling big data and real-time analytics because they can scale horizontally to handle large volumes of data and can process data in real time. So this makes them ideal for applications such as IoT, social media, and financial trading. For example, Apache Cassandra can be used to store and analyze data from sensors in smart homes and smart cities, and MongoDB can be used to store and analyze customer reviews, social media posts, and website log data. Next is flexible schema. So NoSQL databases are also well suited for applications where the schema of the data is not fixed and can evolve over time. So this is because NoSQL databases do not require a rigid schema, which makes it easy to add a new field or change existing fields without disrupting the application. So for example, the CMS or content management systems often use NoSQL databases to store content because the schema of the content can vary widely depending on the type of content. And then a CMS may need to store blog posts, articles, images, and videos, all of which have different data structures. So user-generated content, or UGC, platforms also often use NoSQL database to store user-generated content like social media posts, reviews, and comments. This is because the schema of UGC can be unpredictable and difficult to define in advance. And then NoSQL databases can also provide low latency access to data, making them suitable for high-velocity applications. So this is because NoSQL databases are designed to minimize the time it takes to read and write data. So just like Twitter uses Redis, Redis allows Twitter to deliver tweets to users as soon as they are posted. And gaming leaderboards also often use NoSQL databases to store and update leaderboards in real time. So this allows gamers to see their progress and the progress of other players in real time. And then next we have the distributed and horizontal scalability. So NoSQL databases are designed to scale horizontally across commodity hardware. This means that they can be scaled up or down to meet the changing needs of an application without having to make significant changes to the application structure. For example, the DynamoDB can scale to handle millions of requests per second, making it ideal for applications with an unpredictable workloads. And Cassandra's horizontal scalability allows Facebook to scale its messaging platform to handle billions of messages per day. Okay, and then next is we have graph data, wherein NoSQL graph databases are a type of NoSQL database that is specifically designed for storing and querying graph data. So graph data is data that consists of nodes and edges, where nodes represents entities and edges represents relationships between entities. Graph databases are well suited for applications where the relationships between data are important. For example, graph databases can be used to store and query social networks, fraud detection systems, and knowledge graphs. So we have Neo4j as a popular NoSQL graph database that is often used for social networks. Neo4j can be used to store and query the relationships between the users in a social network, such as friendships, likes, and shares. Also, a fraud detection system may use a graph database to store and query the relationships between bank accounts, credit cards, and IP addresses. And lastly, we have the document storage. So NoSQL document databases are a type of NoSQL database that is specifically designed for storing and querying semi-structured data. Semi-structured data is the data that has a loose schema, meaning that the data can be stored in different ways. So document databases are well suited for applications where the data is semi-structured or JSON-like. For example, document databases can be used to store and query customer profiles, product catalogs, and website content. Okay, so in summary, NoSQL databases are preferred for scenarios involving unstructured or semi-structured data, scalability, and flexibility. So the choice between SQL and NoSQL often depends on the specific requirements of the application and the nature of the data being handled. Okay, so now let's highlight the key distinctions between SQL and NoSQL databases. Let's start with knowing how they differ from each other. So to decide which database you should use, you have to know the major differences between them. It will make things a little clearer, and it will also make it easier for you to choose. So here, we will have some practical points to differentiate SQL from NoSQL. First one is the language. SQL database use the structured query language for querying and manipulating data. SQL databases contain a predefined schema for defining and manipulating data and employ structured query language. So it is one of the most versatile and extensively used query languages, making it a safe bet for many applications. On the other hand, NoSQL databases may differ query languages or may not have a standard query language. In NoSQL databases with dynamic schemas, unstructured data is stored in several ways. You can use a column-oriented, document-oriented, graph-based, or key-value store to store your data. Next is the structure. So a structure is the building block of a database. Within a database, related data are grouped into tables, which consist of rows and columns, like a spreadsheet. So in terms of structure, SQL is a relational database, while NoSQL is a non-relational database. So SQL databases uses a table-based structure. The columns describe general fields found in all entities, and the rows contain descriptive information on single units. In contrast, NoSQL uses a non-fixed schema. It handles unstructured data. It uses key-value pairs, column-oriented, document-oriented, and graph-based models. This makes SQL databases a better option when managing multi-row transactions, such as in accounting systems. Refer to the figures. So this first one is the structure for SQL, which shows a database with relational data for each of the table of data. This second figure, which is for the NoSQL structure, shows a more free-flowing structure. So basically, SQL stores data in a uniform and organized table-based structure, while NoSQL structures its database based on the data that it's storing. So SQL is basically like an accounting spreadsheet, while NoSQL has more freedom in terms of its structure. Next is the scalability. So scalability is the ability for IT systems, such as applications, storage, databases, and networking, to continue to function properly when changed in size or volume. So it often refers to increasing or decreasing resources as needed to meet the higher or lower demands of any business. So NoSQL offers a higher scalability potential than SQL. SQL uses a table-based structure that has a rigid schema. So to scale, it may be essential for you to upgrade to existing computer hardware, which could raise the operating costs for the organization. In contrast, NoSQL uses a non-fixed schema that can utilize multiple hosts to manage large data volumes to facilitate scalability. This makes NoSQL a better alternative for organizations with scalability requirements, meaning SQL is less efficient as opposed to the NoSQL, which can use multiple hosts. Next is the property. So SQL ensures a transaction that has properties of atomicity, consistency, isolation, and durability, or the ACID. So transactions access data using read and write operations to modify the contents of the database. Atomicity means that the entire transaction occurs at once or not at all. You can achieve atomicity through complex mechanisms such as journaling and logging. Consistency ensures that you can only write valid data that follows all rules and constraints in a database. Isolation enables you to make several transactions concurrently without creating inconsistency in the databases. Durability refers to the persistence of committed transactions, so it ensures the storage of data changes to the system's permanent memory, such as hard disks, to prevent data loss during a system failure or outage. So the ACID properties provide data reliability and integrity to the DBMS. In contrast, NoSQL uses a brewer's consistency, availability, and partition tolerance, or the CAP theorem. So this dictates that it's impossible to achieve all three properties simultaneously in a distributed system. As such, you can decide which trade-offs to make between the three functionalities according to unique system needs. So CAP stands for consistency, availability, and partition tolerance. The theory states that within distributed data stores, it's only possible to optimally achieve 2 out of 3 of these characteristics. This is developed by Eric Brewer in 2000 as a theorem stating that there's an inherent compromise between these 3 factors in distributed database systems. For example, we could have consistency and partition tolerance, but they would come at the expense of availability in your database management system. In terms of support, since SQL has been around much longer than NoSQL, it has a built larger following over the years and has garnered a lot of support from the community. So great support is available for all SQL databases from their vendors. Also, a lot of independent consultants are there who can help you with SQL databases for very large-scale deployments. But for some NoSQL databases, you still have to rely on community support, and only limited outside experts are available for setting up and deploying your large-scale NoSQL deploy. Of course, since we now have tackled the differences between SQL and NoSQL, we will also be talking about the ways that they are similar. So SQL, or structured query language, and NoSQL, or the not only SQL, are 2 different types of database management systems, each with its own characteristics and use cases. However, there are some similarities between them. First is the purpose. So the purpose of both these database management models is to offer data management solutions to organizations, giving organizations a way to manage their databases efficiently. So both SQL and NoSQL databases serve as tools for data storage and retrieval. They provide a structured way to store and access data, regardless whether it's textual, numeric, includes dates, or even contain multimedia elements like images. So in both cases, the database facilitates the organization and management of data, which is essential for various applications and systems. And despite their differences in data models, both SQL and NoSQL databases share the common goal of data management. So SQL databases use a relational model, which enforces a structured tabular format for data storage with relationships between tables. In contrast, NoSQL databases use non-relational data models, offering more flexibility in terms of data structure, so including document-oriented, key-value, column family, and graph databases. So the choice of model depends on the specific requirements of the application, but the ultimate aim is to efficiently manage data. So in summary, the key similarity between SQL and NoSQL databases lies in their role as foundational data management tools. They share the fundamental tasks of data storage, retrieval, manipulation, and providing solutions for organizations, even though they may employ different data models and are suited to distinct use cases. So the choice between the two depends on the specific needs and requirements of the application or system you are developing. Organizations often use a combination of these databases to address different aspects of their data management requirements. Next is simplicity. So both SQL and NoSQL databases strive to provide an accessible and straightforward user experience for developers and database administrators. The structured nature of SQL, with its standardized query language, makes it relatively easy for new users to learn. And NoSQL databases, particularly document-oriented or key-value stores, often offer a more flexible and schema-less approach to data storage. So this flexibility can make it easier to adapt to evolving data structures and application requirements. Also, both databases typically come with user-friendly interfaces and tools that make it easier to manage, query, and interact with the databases. SQL databases often provide graphical user interfaces or GUIs or command line tools that simplify tasks like creating and managing tables, writing SQL queries, and viewing database schemas. NoSQL databases also offer user interfaces and tools that cater to their specific data models, such as JSON document editors or key value management interfaces. So in summary, both SQL and NoSQL databases prioritize ease of learning and usage. SQL databases provides a structured environment with a standardized query language, while NoSQL databases offer more flexibility, particularly when dealing with unstructured or semi-structured data. So both types come with user-friendly interfaces, extensive documentation, and community and vendor support to assist users in effectively utilizing the databases for their specific needs and use cases. Next is in terms of scalability. So both SQL and non-SQL offer scalability options. SQL databases are typically designed for vertical scalability, which is also known as scaling up. So vertical scalability involves adding more resources to a single server or upgrading the existing server's hardware to handle increased loads. NoSQL databases excel at horizontal scalability, also known as scaling out. So this approach involves adding more servers to a distributed cluster to handle increased workloads. So in summary, both SQL and NoSQL databases recognize the importance of scalability, but offer different approaches to achieve it. So SQL databases are more suitable for applications where vertical scalability can meet performance requirements, especially when data consistency and structured schemas are paramount. So NoSQL databases are preferred for applications that require horizontal scalability as they efficiently manage the challenges posed by dynamic and rapidly growing data and traffic loads. Next is in terms of support. So SQL and NoSQL have user support systems. This may be community systems or vendor support. So they have established a support system in place to assist users, developers, and administrators. These support systems are crucial for addressing questions, providing guidance, and resolving issues related to the respective database technology. So in summary, both SQL and NoSQL databases offer support systems to assist users, but they differ in the size and nature of their communities. SQL has a well-established and broad user community, making it easier to find solutions to common problems and access a wealth of resources. On the other hand, NoSQL databases have a rapidly growing network of users and developers, which is more closely aligned with emerging technologies and use cases. Now, in security, both SQL and NoSQL databases prioritize security by offering a comprehensive set of features, including user authentication, authorization, and encryption of data at rest and in transit. So these shared security features are critical for maintaining the confidentiality, integrity, and availability of data stored in SQL and NoSQL databases. These measures help protect against data breaches, unauthorized access, and ensure that sensitive information remains secure throughout its life cycle. Now let's have a comprehensive comparison between the two databases. So in conclusion, the SQL and NoSQL databases are both powerful tools for managing data, but they have different strengths and weaknesses. So SQL is a good choice for applications that require complex queries and structured data, while NoSQL is a good choice for applications that require scalability and flexibility. Both SQL and NoSQL databases have their own advantages and disadvantages also. So the best database for you will depend on your specific needs. If you need a database with strong data consistency and integrity, and you can tolerate slower performance for complex queries, then SQL is a good choice. But if you need a database that can scale to handle large data sets and store and manage unstructured data, then NoSQL is a good choice. Here, as for each advantages, you can see that SQL databases shine in terms of data consistency, structured querying, and well-established communities, while NoSQL databases offer horizontal scalability, adaptability, and rapid growth, well-suited for modern, evolving data needs. For each of the disadvantages, SQL databases can be less flexible and may face challenges with scaling out. So NoSQL databases may sacrifice some degree of data consistency in favor of scalability, which can be a disadvantage in applications that require strict data integrity. So as you consider your database needs, remember that the choice between SQL and NoSQL isn't a matter of one being universally superior to the other. Instead, it hinges on the specific requirements of your applications and the nature of your data. And lastly, for each key features, SQL databases are associated with the ACID properties, strict schemas, and structured querying using SQL. NoSQL databases encompasses a diverse range of models, including document stores, key value pairs, column family stores, and graph databases, offering unique options for various use cases. So remember, the choice between SQL and NoSQL hinges on your specific project requirements, data characteristics, and scalability needs. The ideal solution may even involve a combination of both to meet different aspects of your application. So as you navigate the dynamic landscape of data management, we hope that today's insights have empowered you to make informed decisions. But always keep in mind that the best database solutions is one that serves your project's current and future needs effectively. So your data management journey is now in your hands. Choose wisely and may your database empower your applications and businesses to thrive. Thank you.